it's Mrs. Mafucci. Let's continue our study of thermodynamics. Thermodynamics is the study of energy changes that accompany physical and chemical reactions. When studying physical and chemical reactions, a chemist focuses on the following changes. Number 1, changes in enthalpy, or delta H. Number 2, changes in entropy, or delta S. And lastly, number 3, Gibbs free energy, delta G. In the study of these changes, a chemist can determine if a particular reaction or process is spontaneous. A spontaneous reaction is a process that will occur with no outside intervention. Spontaneity has nothing to do with the speed at which a reaction occurs. Do not confuse spontaneous with instantaneous. Instantaneous has to do with rate. Thermodynamics provides no information about the amount of time it takes for a reaction to occur. Kinetics, on the other hand, is the study of the rates of reactions. Gibbs free energy, delta G. Gibbs free energy is a very difficult concept, especially at the high school level. But just know that Gibbs free energy is the energy associated with a reaction that can be used to do work. It is the relationship between temperature, change in enthalpy, and change in entropy during a reaction, using the following formula. Delta G equals delta H minus the temperature times delta S. When calculated, delta G is used to determine the direction of a chemical reaction. For example, if delta G is negative, when you plug it into that formula, if you get a negative number, that means that the forward reaction is spontaneous and no outside intervention is necessary. It also means that the reverse reaction would not be spontaneous. If delta G is positive, however, that means that the forward reaction is not spontaneous and will not occur without outside intervention. An example of outside intervention might be increasing or decreasing the temperature. If the delta G is positive for the forward reaction, that would mean that the reverse reaction would be spontaneous because its delta G would be negative. Well, how does the enthalpy tend to change in a spontaneous reaction? In general, the enthalpy decreases. Spontaneous processes tend to be exothermic, so that the products are at a lower energy than reactants. Remember, the lower the energy, the more stable. Exothermic processes produce or yield more stable products. Well, how does the entropy tend to change in a spontaneous reaction? Both chemical and physical processes spontaneously go to a direction of increased entropy. Entropy is randomness, confusion, disorder. If entropy increases, that means that delta S is positive. So if you look at these 5 cards right here, they're perfectly arranged. That has a lot of order. The spontaneous reaction would be totally messing up that arrangement. As disorder increases, entropy increases. Suppose you emptied a truck full of bricks. Which of the above pictures represents the most probable arrangement of the bricks? Based on the second law of thermodynamics, in nature, most things go to an increase in entropy, randomness, disorder, chaos. Figure B is the most probable arrangement of bricks that would occur. What would be necessary for figure B to change into figure A? Would that be a spontaneous process? Could it occur naturally, say by the wind or an earthquake? Processes that increase the order of a system are possible, but they require the input of energy. For example, the assembly of a protein from amino acids and the production of sugar by plants from carbon dioxide and water are systems that require the input of energy to overcome the tendency to become more disordered. Well, let's look at entropy of various systems. The entropy is greater in gases than in solids. The entropy of a gas is greater than the entropy of a liquid, greater than the entropy of a solid. Larger volumes of gases have greater entropy than smaller volumes. Larger numbers of gas molecules is greater in entropy than smaller numbers of gas molecules. Higher temperatures have greater entropy than lower temperatures. In other words, as temperature increases, the entropy of the system increases. Dissolved solutes have greater entropy than undissolved solutes. The entropy of a solution is much greater than the entropy of a solute and solvent. Bigger molecules have greater entropy than smaller molecules. That's because there's more chemical bonds and more complexity. Bigger atoms also have greater entropy than smaller atoms because there are more electrons, protons, and neutrons. Entropy, randomness, disorder, confusion, chaos. If delta S is positive, that means that the products are more random or disordered than the reactants. And if delta S is negative, that means that the products are less random or disordered than the reactants. In general, reactions tend to go such that delta H is negative, that is, exothermically. In nature, reactions tend to release energy, causing the products to be more stable. In general, reactions tend to go such that delta S is positive, which means that in nature, reactions tend to occur which cause the products to have more disorder or randomness than the reactants. So, some Saturday morning, if your mom comes into the room and kicks you when you're sleeping on your bed and says, "Get out of bed, you lazy bum, and clean this mess," you can just say, "But Mom, I'm just following the laws of thermodynamics. I've run out of energy and, well, my room is supposed to be a mess." So let's now go back to Gibbs free energy. What does it mean if delta G is negative and the reaction is spontaneous? Delta G will always be negative if delta H is negative, exothermic, and you're going to subtract temperature times delta S. If delta S is positive, that means you will always get a negative value for delta G if delta H is negative and you subtract a positive delta S. In other words, if the process follows the two tendencies in nature for reactions to proceed exothermically and an increase in entropy, that reaction will always be spontaneous. All reactions that progress with a decrease in enthalpy and an increase in entropy will be spontaneous.